Hi, welcome back. In this video we're going to continue our discussion. We're going to talk in this one about the actual derivative of the natural log of x. To find the derivative of the natural log of x, we're not going to prove it in this video. To do that we would be using implicit differentiation. But we're not quite there yet, and we would need to know the derivative of e to the x. We haven't talked about this yet, so we'll talk about that in a future video. To get the derivative of the natural log of x with respect to x, we're going to get this 1 over x. That's our rule. That's our rule for today. The derivative of the natural log of x is just 1 over x. Sometimes you'll see books do this. They'll use the letter u. In that case, it's just going to become 1 over u times, this is more of a chain rule. U is another function, but it's in terms of x. So we're going to use a chain. And that's going to become times the derivative of u, or u prime. So they'll write it u prime over u. I don't really normally use this rule myself, but some people do tend to like it, and that's okay. Whatever helps them. So let's see here. Let's take a look at some derivatives. The first one says we want to find the derivative of the natural log of 2x. Now there are going to be two ways we're going to do this, okay? The first way, we're just going to use my rule. My rule says to take 1 over x. Now you do have to be very careful here. Because with natural log of x, kind of like trig, there's always some sort of chain rule for us on these. So when I take the derivative, option 1, I'm just going to get f prime of x is, my rule says it's just going to be 1 over x. Well, my x here just is 2x, so I'm going to get 1 over 2x. So we just get 1 over whatever on the inside. Multiply that. Now there's a chain rule because there's an inside. The derivative of 2x is just 2. And there's my answer, and I can leave it like that. But I can also simplify it. If I simplify it, the 2's will cancel, and I get 1 over x. Now, another way we can do it is we can use our properties. That's right. This is why we have log properties. My log property here says if I'm multiplying, I can rewrite this as addition. So I can write this as the natural log of 2 plus the natural log of x. Now you might be thinking to yourself, why would you want to do this? There are going to be some cases, we'll talk about later on, where this would make it much easier for us. When we take the derivative, dy dx, the first one, this is just a constant. Its derivative is just going to become 0. But here we go, this just becomes 1 over x, which is what we had over here. So we do get the same exact answer. And now, like I said, you might be thinking, okay, for number 1, option 1 is pretty easy, if not easier than option 2. However, there are going to be situations which we are going to be wanting to use option 2. And we'll talk about those when we get there. So let's take a look at number 2 here. When we take the derivative, we're going to get y prime, or dy dx, whatever you like. This is always a chain rule. My outside is this natural log. My new rule says this is going to become 1 over x squared plus 1. We're going to multiply that by the derivative of our inside. Well, what's the derivative of x squared plus 1? Dos equis. Stay nerdy, my friends. And there's our answer. There's our derivative. Now, we are going to have to use our other derivative rules as well. For example, in number 3, notice we have this x times this natural log of x. We are going to have to use the product rule here. So when we look at this one, when we take our derivative, my rule says the product rule, don't forget, is the first times the derivative of the second plus the second times the derivative of our first. So we're going to write this as x times the derivative of natural log of x, that's our rule for today, 1 over x, plus the second, which is natural log of x, times 1. You can leave it like this, or you can clean it up. The x's cancel. We get 1 plus the natural log of x. And there is our derivative. Look how easy that is. So easy, even a senior can do it. All right, let's take a look at number 2. Oh, no, number 4 here. Oh, my gosh. It's escalated quickly. For here, same thing. I'm going to use my product rule. Product. But be careful, on this one, we are going to have a chain, because that's natural log of x cubed. Put that x cubed in parentheses doesn't make it a little bit easier, more obvious for us. So when we take the derivative, we would get dy dx, the first being 2x times the derivative of the second. My derivative natural log of x cubed is 1 over x cubed, but we do have a chain rule. I'm going to multiply that by the derivative of the inside, which is 3x squared, plus the second, which is natural log of x cubed, times the derivative of 2x, which is just going to be 2 there. Now, there's a lot I can do to clean up on this one if I wanted to, but you know what? You can leave it like this if you want. But if you're like, yo, Mr. Warner, I'm feeling pretty confident I can simplify this, this is just going to become 6 plus 2 natural log of x cubed. I mean, don't be a hero. You can always go further with logs. That's why people don't like logs. I can write this as 6 plus the natural log of x to the 6 if I wanted to. Don't be a hero. Leave it right there. You're good as gold on the derivatives here, okay? The problem, and I think why people don't like logs so much, is that there's so many ways you can simplify them, so just keep it easy. All right, for question number 5. Now, again, for this one, I'm actually going to use my property. I told you there's going to be times when you're going to want to do this. And if I don't use my property, I'm going to have this ugly little chain rule right there, and I don't like that. So when I take my derivative, we're going to get, I'm not going to take my derivative yet. I'm going to rewrite it. The natural log of x plus 1 to the 1/2. The property I'm going to use is my power rule. Now, this is not a derivative. This is just a log. This is just a property of logarithms. I get 1/2 the natural log x plus 1. And what I like about this is it's going to make it a much nicer derivative to take. We get f prime of x, 1/2 times, and then the derivative natural log of x plus 1, well, that's my new rule, 1 over x plus 1. And there's your answer. So let's say you decided to not do this rule. I'm going to do this one in red because it's bad, okay? Let's say I decided not to use my property here. Well, I would get the derivative. The derivative of the inside, I would get 1 over x plus 1 to the 1/2 times the derivative of the outside, which is 1/2 x plus 1 to the negative 1/2, chain rule times 1. Fix my negative exponent, 1 over x plus 1 to the 1/2 times 1/2 times 1 over x plus 1 to the 1/2. And these two together give me x plus 1. I get the same answer. It's just going to be a lot messier. And that's why logs have properties, because they're going to allow us to they're going to allow us to work these problems simpler. So let's take a look at another one using our property. Number 6. Here we go. Oh, this is the cube root. So I'm going to rewrite this as the natural log of x squared minus 1 to the 1/3. And we do just, if I were to take the derivative now, it's pretty ugly. So I am going to rewrite this as 1/3 the natural log of x squared minus 1. And I get rid of that exponent. That exponent creates a chain rule for us, which is a mess. We don't like that. So instead, this makes it a little bit easier for us. Now, so what's our rule here for? What's our rule that we're going to be doing? Oh, well, we will have a chain rule again, because I can't distribute the natural log. It would be nice if we could. So when we take our derivative, sorry about that, we get to 1/3 times, this just becomes 1 over x squared minus 1 times chain rule the derivative of the inside, 2x. And there's your answer. Don't do anything fancy. All right. Yo, I heard you like natural logs, so I put a natural log inside your natural log. This is a fun one. So when we take the derivative, we are going to use a chain rule again. Chains everywhere. Chain, chain, chain. Right? Chain rules everywhere for us. When we take the derivative, we're going to get 1 over, the derivative of natural log is 1 over whatever on the inside. So we get 1 over natural log of x times, but now we got to do the inside. Well, what's the derivative of natural log of x? Oh yeah, that's just 1 over x. There's your derivative. Easy peasy. What if I did this? What's the derivative of the natural log of x? What? We would get what? 1 over the natural log of the natural log of x times inside 1 over the natural log of x times the inside 1 over x. And we can just go on and on and on and on. And we'll stop there. I won't go too crazy. All right. If you go to the next video, we're going to take a look at a bunch more examples. So I hope to see you then. Bye.